Okay, dilations, we've already kind of done these. Remember a dilation, like when your eyes dilate, what happens? Smaller. So a dilation, all it is it's a reduction or enlargement. It's the same thing. The reason why this is in here is because it's proportional. If you take a picture and you make it bigger, that's an enlargement. And remember, you got to do it proportionally, or what happens to the picture? It's distorted. Same thing when you reduce it. If you shrink it, you got to shrink it proportionally. So the two types of dilations are reduction or enlargement. So if they tell you to explain it, that's all you got to do. If it gets bigger, it's an enlargement. If it gets smaller, it's a reduction. And then what they do is you got to say its scale factor. How much smaller does it get and how much bigger does it get? Remember when we did scale factors of two things, what do you got to do to find the scale factor of something? It's just the ratio of the sides, right? This one, the scale factor is 6 to 10, which you could reduce. You could divide them both by 2, you'd get 3/5. Now, this is where before we really didn't, unless they told you which way to do it. This is 3/5, or it could be 5/3, depending on where you go. If this is the original and it goes to that, what's happening to it? Enlargement, right?
Yeah.
So that helps you decide which number to use for the scale factor. It's going to be 3/5 or 5/3. One of these represents an enlargement and one represents a reduction. Since this is an enlargement, which one of these two would you have to put?
5/3.
And do you know why?
Because the bigger number's on top.
Right, it's greater than 1. If it's greater than 1, it's going to be an enlargement. If it's less than 1, it's going to be a reduction. Okay? So that's how you decide which scale factor you use. So in this picture, here are the actual two triangles. If you remember, we kind of did some drawings like this before. And this is how you do perspective drawings. You guys do those in art?
Yeah, fortunately.
Okay. Here's the point of reference, and then measuring from here to here, it's 3 whatever, and then from here to here, it's 5. Now, you can tell which one's the original. Which one, the big one or the small one's the original? The big one, because it's just a regular P. This one has a P prime on it. Remember, the prime is the image. So, to identify it, this is the original, and this is the image. So, is it an enlargement or reduction?
Reduction.
So, it's a reduction. And then the scale factor. All you got to do is pick 2 corresponding numbers on the picture, which there are only 2, so it's hard to mess this one up. It's either going to be 3 to 5 or 5 to 3. Which one's it going to be? 3 to 5, because it is a reduction. 5 to 3 would make it bigger because that's greater than 1. So this one, here is the P prime, which means this is the image. So that's after it's been changed. So this has gotten bigger, so it's an enlargement. And then the scale factor, it's either going to be 12 to 5 or 5 to 12. Which one does it have to be? 12. Since it's an enlargement, it has to be 12 to 5 because it's greater than 1. So here's how you do a dilation on a coordinate system. They have this triangle, X, Y, Z. They want us to have a scale factor of 2. We did this on a test before. All you got to do is double times 2 all the points. Remember doing that?
Yeah.
So all you got to do is take the scale factor times each point. So take that times 2 and take that times 2. That would give you 2, 2. This would give you 10, 2. So this is gonna be the new triangle. X prime, the new x, is 2 over 8 up. Y prime is 2 over 2 up. Just use another color. And Z prime is 10 over 2 up. So here is a new triangle that is twice the size, or a scale factor of 2, of the original one. So they tell us to find the perimeter. We're not going to worry about that as much, but you should, this is kind of a refresher for you. The perimeter of this blue one, this is 1, 2, 3, 4. This is 1, 2, 3. So remember how you can find that?
The distance formula.
You could use the distance formula, or quicker yet, it's a Pythagorean theorem. To find the hypotenuse, you got to take 3 squared plus 4 squared and then square root it. Remember, if you're looking for the hypotenuse, you add them. That turns out to be 5. So this perimeter is 12. Okay. Any guess on what this perimeter is before we solve it? Just take the scale factor, right? So we could solve it, but it's going to end up being just double the perimeter. Okay, so in this one, it's got a lot going on. It has a diamond right there, and that's the image because it has the little prime marks on it. So this is the original.
So it was a reduction.
So it is a reduction, yes. So, and then they just drew these perspective lines in here. You don't always have to use those. They're just, I should use them. Okay? Sometimes they're used, sometimes they're not.
You see,
No.
you need to use them? You can just
You don't need to use them, no. Now to find the scale factor, you can choose any lines that are corresponding. So if I knew what these were, I could use them. But remember, I'd have to use the distance formula to find lengths if they're diagonally. So if you ever had to find a length, what's the easiest lengths to find on a coordinate system? What kind of?
Oh, the straight line.
Right, side to side or up and down, right?
Yeah.
Well, if you look at this green one, it doesn't have, they're both angled, or all 4 of them, and here
do you do the
too.
middle.
Right, you don't need to use the outside edges. You can use any corresponding lengths. So what I could do is I could use this,
So 2.
and I could use this. Now, that looks like it's halfway, I'm not sure. So if you're not positive, you could just do up and down instead. So this one from point to point is 1, 2, 3, 4, right?
Yeah.
This one from here to here is 10, which is 2/5. So, it's either going to be 2/5 or 5/2. Since it's a reduction,
2/5.
it's the 2/5. Okay? The coordinates of the image, we're not going to worry too much about that because we've already done so much of it. But the image is this one. So M prime is 3 over 2 up. Q prime is 2 over 0 up. N prime is 4, 0. And P prime is 3, negative 2. Okay? Most of them that we're going to do in today's assignment just look like this.
You know what?
Reduction, enlargement, and then what's the scale factor?
Good job, Connor. I don't even think it's worth the time.
You don't?
Yeah.